Now we are going to show one example of DLE factorization using the echelon matrices. Okay, consider this matrix A, and we want to, so what we want to do is A times some kind of L1, E1, E2, until the last E, so that it can give me an upper triangular matrix. So that's the general picture. E1 is equals to a n by n matrix. Just let one on the diagonal. The rest are all 0 in here. We want to represent this as a Gaussian elimination. In Gaussian elimination, we want to multiply 1/2 on the first row and then add that to the second row so that we can make this as a 0. And for this one, we want to multiply the first row by 1 and then add that to the third row so that we can make this 0. So this is a 1/2 multiply added to here. So I write that in here, and then 1 add that to here. So I put that in here, and then 0. And then I let all of this equal to zeros. If I do E1 times A, this basically copy the first row for the A. So it'll be 2, -1, 0, and 0. This one basically multiply 1/2 to here, the first row, and then add that to the second row because we have a 1 here. This multiply 1/2 and add that to here, which gives me 0. This add 1/2, multiply 1/2, which is -1/2 plus 2 in here. So which gives me 2/3, 3/2. And if we keep doing this for the, so here and here, which gives me -1, here, here, and here, which so it gives me 0. So now we can move to this row. So this times 1 plus this times 1, it will give me the addition of this. So it will be 0, -2, 2, -1. For the last one, in here, it's basically copying the last row. So I just copy the entire thing. So you can see the echelon matrix actually reduce this to zeros. And we can continue the steps. We let E2 is equals to, so we want to further eliminate this matrix. So I want to make this into 0. Okay, first we write down the echelon matrix, 1 on the diagonal, 0 in here. And we already done this, so just put this 0 in here. So what we want to do in here is to multiply some quantity in here and then add that to here. That's basically the idea of Gaussian elimination. If I multiply 3/2 by 3/4 and then add that to this row, then this eliminates and get 2. This gives me a 0. So that's what I want. So the multiply is 4/3. So we put that in here. Okay, how about for the last row? We want to multiply 2/3 and add that to the last row. So this is 2/3. So the result of E1A, E2 is equals to 1, 0, 0, 0, 0, 0, 0, 1, 4/3, 2/3, multiplied by E1A, which is our previous result. So I just copy it. Okay, let's do the multiplication. So this is 1, 0, 0, 0. So basically copy the first row. 0, 1, 0, 0. So basically copy the second row. And this is multiply 4/3 to this row and add that to the second row on the third row. So let's work this out, which is equals to this 2 cancel out. And so that's equals 0. This is 0, so this get -1. For this term, 2/3. So that's the result. Just copy that back. So that's 0 in here, and then 2/3 in here, -1 in here. Okay, for the last step, we just multiply this by this. So this row times this column equals to 0. This row times this column, this row times this column, it gives 2 times 3, multiply 3 times 2, and then minus 1, which is equal to 0. So that's expected. So we do the another column, it will be 0 times negative 2 over 3 plus 0 minus 1. And that gives me negative 3 over 5. 5 over 3. The last one, it will give me 2. Okay, for the final step, we want another echelon matrix, which is E3. 1, 1, 1, 1. This is 0. And we already done this, so to set this to 0. And for the last one, we want to reduce this part to 0. So we want to multiply it by 5 over 2. That will become, so 5 over 2 times 2 over 3. Add that to the last row, gives me 0. So that's what we want. So we put 5 over 2 in here. So that's our last echelon matrix. So as a result, we copy E3 and then multiply the result of the previous ones, which is equals to 1, 1, 1, 1, 0, 0, 0, 0, 0, and 5 over 2 times the result in here. Just copy this. Okay, let's do the multiplication. So you can see this is 1 and the rest are 0, so basically copy the first row. This is 1, the rest are 0, so copy the second row. This is 1, the rest are 0 as well, so copy the third row. Okay, for the last one, we ignore the first 2 rows because there's 0 multiplying here. Basically, we are focusing on these 2 rows. So it will be 0, 0, and 5 times 2, and 5 over 2 times 2 over 3, plus negative 5 over 3. Another one is negative 5 over 2 plus 2. So that this one cancels out, so it equals 0. This one will be negative 1 over 2. So this is 0, this is negative 1 over 2. And as you can see now, it becomes an upper triangular matrix U. Okay, so what have we done so far? We used the row echelon matrix to multiply the A, and then we reduce that to the result of the forward elimination, which is an upper triangular matrix. And the next step is to multiply these guys, which give me a L inverse, and we can just let A equals to L and U. But don't be scared by the inverse. Okay, so right now we need to find the L for this LU factorization, and we already know that E1, E2, and E3. E1, E2, and E3. So we want to find L. There's a trick in finding the L. So L is basically, so first, L is a lower triangle matrix. You can check the dimension. A is m by n, which means after I reduce A, U should be m by n as well. So L should be m by m. So this should be a 4 by 4 in our case. So first, I made the diagonal is equals to 1. Secondly, for each entries, non-zero entries, I just negate and put that in here. So that gives me 1 over 2 negative and negative 1. The 0 I just gives 0. For E2, we get negative 4 over 3 and negative 2 over 3. For the last one, it was just negative 5 over 2. So that's the L we are getting. And we get U, which is from our previous Gaussian elimination or our previous LU factorization steps. We got our U was equal to this. So now we know L and U. then we have already done the LU factorization step. Yep, so that's it.